This is my circular motion reassessment. So Oak Ridge subdivision is in the process of laying asphalt, and at the end of the street they are making a circle. It is a flat circle with no bank. The radius is 50 meters. The coefficient of static friction between a tire and the road is 0.4. The city of Hammond is trying to figure out what should be posted as the speed limit for this turn in meters per second. So this is my circle, and this is my radius, 50 meters. I also know the coefficient of static is 0.4. It's my force body diagram, and I have a normal force, force of gravity, which is mass times gravity, my frictional force, and this is my radius because the car is heading this way. So I put the sum of the forces in the y direction equals 0, and then sum of the forces in the x direction is mass times acceleration in the x direction, and then simplify that to, because acceleration is velocity squared over r, so mass velocity squared over r, and then I took my y component and I put my force normal, which is heading in the direction up, so it's positive, and since gravity is down, I put negative. Mass times gravity equals 0, and then I solved for my normal force, so normal force equals mass times gravity. And then I took my x equation again, and then I put my force of friction equals mass times velocity squared over the radius, and then I put the coefficient of static times my normal force equals mass times velocity squared over r. Then let's see what I did here. My normal force, I'm sorry, I'm having trouble holding my phone. My normal force, my normal force is mass times gravity, and then I carried everything else down to get rid of m, because m's on both sides, and then I times the radius to both sides to cancel radius on this side, and that leaves me with velocity squared equals coefficient of static times radius times gravity, and then I took the square root of both sides, cancel out the square, so my velocity equals the square root of the coefficient of static times the radius times gravity, and that's my final formula. And then I plug in what I knew, and that gave me 196, or square root of 196. I took the square root, and that's 14 meters per second. That is my circular motion problem.